Look up at the night sky. The stars appear still, silent, frozen in place. But that stillness is a lie. Everything you see, every star, every planet, every galaxy is spinning right now, at this exact moment. The Earth spins at 1,600 kilometers per hour. The Sun drags our entire solar system through the galaxy at 800,000 kilometers per hour. And the galaxy itself rotates, a slow, colossal wheel, taking 230 million years to complete one turn. But here's the question no one thinks to ask. Why? Who started it? Who pushed the first domino? In everyday life, nothing moves unless something moves it. You kick a ball, you press a key, you step on the gas. But the universe had no one to push it. And yet, it spins. The answer stretches back 13.8 billion years, to a moment before stars existed, before planets existed, before anything existed. And what it reveals will completely change the way you see the cosmos. The early universe was not empty. It was a vast, hot, churning ocean of gas. Hydrogen, helium, a few trace elements, nothing more. But it wasn't perfectly uniform. In some places, the gas was ever so slightly denser. In others, ever so slightly thinner. Microscopic differences, invisible to any eye. These tiny irregularities, these almost nothing fluctuations in density, were the first domino. Because gravity is patient. Where the gas was slightly denser, gravity pulled slightly harder. Matter began to drift, slowly, almost imperceptibly, toward those denser regions. And as it drifted, it didn't fall in a straight line. It spiraled. Physicists call this the conservation of angular momentum. Once something begins to rotate, even slightly, even almost imperceptibly, that rotation doesn't stop. There is nothing in space to slow it down. No friction, no resistance, no brakes. On Earth, a spinning top slows down because the table pushes back against it. In space, there is no table. The first rotations that formed in those ancient gas clouds 13 billion years ago are still spinning today. Every planet, every star, every galaxy, still carrying the memory of that original microscopic twist. So the gas is spinning, slowly collapsing inward under gravity, rotating faster and faster as it contracts, just like a figure skater pulling her arms in. But here is where something remarkable happens. The spinning cloud doesn't collapse into a ball. It flattens. Think about stirring paint into a bucket of water. If you pour it straight in, it spreads randomly, chaotically. But if you stir in a circular motion, it spirals, it organizes, it forms a shape. Gravity is the hand stirring the cosmic bucket. As the gas cloud collapses, the rotation resists gravity in the plane of the spin, the centrifugal force pushing outward. But above and below the spinning plane, there's nothing to resist the fall. So the cloud pancakes, flattens into a disk, a spinning disk of gas and dust. We call it an accretion disk. And this disk, this flat, spinning pancake of matter, is the single most important structure in the universe. It is the factory where everything is built. Inside the disk, particles collide, gas heats up, friction generates temperatures of tens of thousands of degrees. Matter clumps together. Clumps grow into larger clumps. Larger clumps grow into planetesimals. And planetesimals, given enough time, grow into planets. At the center of the disk, pressure and temperature reach a critical threshold, and a star ignites. Without the accretion disk, without this spinning structure, there are no stars, no planets, no solar systems. The universe stays a cold, featureless fog forever. Rotation didn't just move matter, it organized it.
Now zoom out. Way out. Far enough that individual stars are invisible, that the Milky Way itself is just a faint smear of light. At this scale, the same question appears again. Galaxies spin. We've known this for decades. The stars at the outer edges of galaxies move at hundreds of kilometers per second, fast enough that, by all calculations, they should have flown themselves into intergalactic space billions of years ago. But they haven't. They're still there. Why? In the 1970s, astronomer Vera Rubin noticed something deeply wrong with galaxy rotation. The stars at the outer edges were moving too fast, far too fast. The visible matter, every star, every cloud of gas, every speck of dust, wasn't nearly massive enough to hold them in orbit. Something invisible was keeping them there. Something that had mass, enormous amounts of mass, but emitted no light, absorbed no light, left no trace that any telescope could detect. Dark matter. Dark matter forms an invisible scaffold around every galaxy, a vast, invisible halo of mass that extends far beyond the visible stars. It is the hidden architecture of the cosmos. And the rotation of the galaxy within this dark matter halo works like a gyroscope. Have you ever watched a spinning top resist falling over? It wobbles, it fights gravity. The faster it spins, the more stable it becomes. Galaxies work the same way. Their rotation, combined with the gravitational grip of dark matter, makes them rigid, stable, structured. Without rotation, a galaxy wouldn't be a graceful spiral. It would be a shapeless, unstable cloud of stars, drifting apart in the dark. So far, rotation has been orderly, predictable. A cosmic engineer building structure from chaos. But what happens when rotation becomes extreme? What happens when you take a mass equal to our entire sun and compress it to the size of a city? The answer is a neutron star. When a massive star exhausts its nuclear fuel, it collapses. The outer layers explode outward in a supernova. But the core, compressed by gravity so extreme that protons and electrons are crushed together into neutrons, survives. What remains is a sphere roughly 20 kilometers across. A teaspoon of neutron star material weighs 1 billion tons. And because the original star was already spinning, and conservation of angular momentum has no mercy, as the core collapses, it spins faster, dramatically faster. Some neutron stars complete 700 rotations every single second. Let that settle. 700 times per second. But that's not the strangest part. According to Einstein's general theory of relativity, a massive rotating object doesn't just sit still in space. It drags space itself along with it. Imagine stirring a spoon through thick honey. The honey near the spoon begins to rotate, pulled along by the motion of the spoon. In the cosmos, spacetime is the honey. A spinning neutron star or a spinning black hole literally twists the fabric of the universe around itself. This effect is called frame dragging. If you were near such an object, you couldn't move in a straight line. Space itself would pull you into a spiral. Rotation here is no longer just movement. It is the control of reality itself. But rotation has a limit. Nature, it turns out, has built a failsafe. If an object spins too fast, faster than a certain critical threshold, the centrifugal force simply tears it apart. The object shreds itself into gas and dust. This isn't a coincidence. It's a fundamental protection mechanism built into the laws of physics. The fastest spinning neutron stars, called millisecond pulsars, approach but never quite reach this limit. They are the most precise natural clocks in the universe. Their rotation is so stable, so regular that astronomers use them to test Einstein's theories, to search for gravitational waves, to measure the structure of space-time itself. A spinning dead star, acting as a cosmic timepiece. Rotation becoming measurement. We've traveled from the microscopic fluctuations of the early universe to the most extreme objects in the cosmos. But now comes the most personal question of all. What does any of this have to do with you? Everything. Consider the Earth. It formed 4.5 billion years ago from a spinning disk of gas and dust around the young sun. The rotation of that disk gave the planets their orbits, stable, predictable, mathematically precise paths around the sun. Without that rotation, the planets wouldn't have orbits. They would have fallen directly into the sun, or drifted into deep space. But there's something even more direct. The Earth itself spins, once every 24 hours. And deep inside the Earth, in the liquid iron outer core, that rotation drives a colossal generator, moving electrically charged particles, generating a magnetic field that wraps around the planet like an invisible shield. The magnetosphere. Without it, the solar wind, a constant stream of charged particles blasted out by the sun at 700 kilometers per second, would strip away Earth's atmosphere, molecule by molecule, layer by layer. Mars lost its magnetic field billions of years ago. Today, its atmosphere is less than 1% the density of Earth's. Its surface is a frozen, irradiated desert. The Earth kept its magnetic field because the Earth kept spinning. Your atmosphere, your oceans, your climate, your seasons, your entire biosphere, every living thing that has ever existed on this planet is here because of rotation. Because 4.5 billion years ago, a cloud of gas began to spin and never stopped. Step back one final time. Look at the full picture. A microscopic fluctuation in the density of gas, barely detectable, almost nothing, arose in the early universe. That fluctuation gave matter a tiny angular push. That push was preserved because space has no friction and amplified as matter collapsed inward. The angular momentum shaped collapsing clouds into disks. Disks built stars and planets. Stars and planets formed solar systems. Solar systems collected into galaxies. Galaxies, held together by dark matter and their own rotation, built the large-scale structure of the cosmos. And on one ordinary planet, orbiting one ordinary star, in one ordinary spiral arm of one ordinary galaxy, the rotation of a liquid iron core generated a magnetic field. That field protected an atmosphere. That atmosphere sheltered an ocean. That ocean gave rise to chemistry. That chemistry became life. And here you are. So, why does everything spin? Because the universe was born imperfect. Because those imperfections created angular momentum. Because angular momentum cannot be destroyed. Because the same force that spins a figure skater spins a galaxy. Because rotation is not just movement, it is the universe's memory of its own birth, preserved across 13.8 billion years without losing a single revolution. When you look at the night sky, you are not looking at static points of light. You are looking at the result of a perfectly tuned process that began with almost nothing. A process that built everything. A process that is still running. Right now. In the spin of the Earth beneath your feet. In the orbit of the moon above your head. In the rotation of the galaxy slowly wheeling overhead. All of it connected. All of it spinning. All of it still carrying the memory of that first, almost imperceptible twist. 13.8 billion years ago, when the universe learned to rotate, and everything changed.